Shri Gurubhyo Namaha. Welcome to Shri Sai Guru channel. This is Reshma. Today's topic is real number from the grade 10 standard. I took one question from exercise 1.3. The question is prove that root 5 is a rational number. Dear student, as you know that the meaning of rational numbers and irrational numbers in previous classes, P by Q or A by B form of every number is called as rational numbers. The conditions A and B are any integers, B should not equal to 0 and A and B must be co-prime number. So we shall prove that root 5 is an irrational number by assuming root 5 as rational numbers. So let us assume that root 5 is a rational number. Root 5 is a rational number. You know that already root 5 is an irrational number, but we assume that root 5 is a rational number. So therefore root 5 is equal to A by B, where A and B are integers, and condition B should not equal to 0, denominator should not equal to 0, and HCF of A and B is 1. If HCF of A and B 1 means A and B co-prime number. These two numbers are co-prime number. So let us start the its proof. I already consider root 5 as rational numbers. Then by the cross multiplication, do the cross multiplication, root 5 into B, then A into 1. So there is no number means denominator is 1. So its product is root 5 into B is root 5B, A into 1 is A. Squaring on both sides. Next procedure, squaring on both sides, we will get root 5B whole square equal to A square. That is equal to root 5 square means 5. B square is B into B is B square equal to A square. What it implies? It implies, this equation implies 5 divides A square. 5 divides A square. So if 5 divides A square, 5 also divide. Most important, 5 also divide A. See here, this equation, what is the meaning of this equation? When 5 divides A square, B square is a quotient and the remainder is 0 according to Euclid division statement, Euclid division lemma. Then if 5 divides A, I am writing this statement in terms of equation. What is that? 5 divides A, that is A is equal to 5. A is equal to 5. But the quotient, I will take the quotient as C. The meaning of this is 5 divides A gives the quotient C, leaving remainder 0. So again I will square on the both side. A square is equal to A into A is A square, then 5C whole square. That is equal to A square is equal to 25 C square over. Yes. So now what I will do, I will substitute A square as 5B square. This is, I take as equation number 1. 5B square is equal to A square. I am substituting A square value in second equation. So I am writing clearly here. Substitute A square from equation number 1. So here A square is 5B square. I am substituting A square as 5B square. So here A square replaces 5B square, that is equal to 25C square. So here 5 1s are 5 5s are, we get B square equal to 5C square. See, from this statement it is Notice that 5 divides b square. It implies, this equation implies 5 divides b square. Then 5 also divides b. So I am underlining this statement, these two statements. 5 also divides a and 5 also divides b. So I am converting this in terms of equation, that is b is equal to 5c. B is equal to 5c, where c is an integer. C is a quotient. C is the quotient. So the meaning of this is 5 also divides b. So from these two statements, see these two statements, very important, or you can consider this equation also. 5 divides a, 5 divides b. So the meaning of what we concluded, 5 becomes common factor between a and b. Therefore 5 is a common factor of a and b. But a and b must be co-prime number. What is the condition? If root 5 is an rational number, that is in the form of a divided by b, a and b should be co-prime number. But here what we got the statement, 5 is a common factor. If 5 is a common factor between a and b, then what? A and b are not a co-prime number. It states that a and b are not co-prime number. Are you understanding? A and b are not co-prime number because here 5 is a common factor. Therefore what happened? This statement contradicts the fact that a and b are co-prime number. Understand? Therefore what should I write? Sorry for the disturbance. This contradicts the fact that a and b are co-prime. Very important. So if a and b are co-prime number, then this contradiction arises because of our incorrect assumption that root 5 is a rational number. What we assumed? We assumed root 5 as a rational number, but we got what? Contradictory statement here. What is the contradictory statement? A and b are co-prime number. So therefore root 5 is an irrational number. Therefore we concluded that. Before we have to write here, yes, this is contradictory to our assumption. Yes, our assumption that root 5 is a rational number, and hence root 5 is a irrational number. It is an irrational number, hence it is proved. I hope you understand this video. Please share, comments, and subscribe my Sri Sai Guru channel. Thank you.